Here's a projectile motion problem. I recommend that you pause this video to watch the problem statement, then work it on your own before you resume. Okay, here is a projectile motion problem. This is similar to problem 1-18, but it has been changed a bit in order to protect the guilty, just the numbers. So here's what happens. It says that there's a katydid who is launching itself, and the question is, how far along the ground does this katydid go? So of course, as you know, the first way to operate in this is always to draw a picture. So we're going to draw a picture, and here's the picture. The picture says this katydid is launching itself like so. It'll be hard to see the katydid because they're very small. So I'll just make it like that, and you can use your imagination. It says this katydid is launching itself, and so then here's what happens. The katydid launches itself, and eventually hits the ground. Okay, so let's see, what is it that happens here? It says that we know a few things. It says that the katydid can launch itself at a v of 2 meters per second. Is that right? No, 4 meters per second, all the better. Then it also says that the angle of launch, theta, is 42 degrees. So we have a 42-degree launch angle like so. And it says how far along the ground would such a leap propel this katydid. So how far along the ground? The ground is here, right? So the distance along the ground is this, usually called x, and we don't know what it is. So here's the x. That distance, unknown. We know the v0, we know the theta. So how far does this go? Okay, well, as usual, we need to have some kind of physics principles involved in this. And the physics principles here happen to be actually very handy because we have an equation in the book. And the equation tells us the range along the ground. It says x equals v0 squared over g multiplied by the sine of 2 theta. So then, as usual, you have to figure out what is it that is known, what is it that's unknown, and so forth. This one, we're lucky. This is easy. X, it says, that's the unknown. We don't know what that is. They asked us for that. V0 is 4 meters per second. We know that. The g is the acceleration due to gravity. We know that. The sine of 2 theta. We know the theta that was given. So we're probably in pretty good shape here. So that let's now figure out, whoa, this looks like a large, thin book. So we'll make this up here and say x equals. Now we're going to put in all those numbers because it's already solved for x. We don't have to do it in mathematics. It says v0 squared, so we have 4 meters per second. We have to square that, multiplied by the sine of 2 theta. So this is 2 times 42 degrees. Divided by g, which is 9.81 meters per second squared. Great! So what we have now is purely mathematics. So if you work out the mathematics, here's what happens. It says that this is about 1.62 meters. If you're a fan of the English system, this turns out to be 5.32 feet. So then, you always have to ask the question, is this reasonable? Well, first of all, one reasonable part about it is the unit, meters squared over second squared divided by meters over second squared, the only surviving unit is meters. This is good. It's a distance. We want it to be in meters. The number of 1.62 meters, 5.32 feet, does that seem about right? What, did you ever see a cricket, which I'm sure is like a katydid, jump, and do they jump about 5 feet? Probably seems about right. So it seems maybe this will pass the reasonability test. So we may be good. Great.